and we are the nose retractor group.
It's not plugged in.
Oh,
Oh, yeah, we took out the resistors.
okay, sorry.
Is it a USB? Yes, it is.
It's right on this side. Oh, you got it?
Okay.
Okay, so a little bit of background, again, on our project. We talked with Dr. Knight here at Carl, who's a physician, and he has an issue with when patients come in and they have profuse nose bleeding, he has to do this procedure to cauterize the blood vessel. So what he has to do is he has to retract the nose with one hand, he has to suction out the liquid, at the same time he has a light mounted on his head that he's trying to navigate and point into the nose, and then he has to cauterize the blood vessel. So that's a lot of different actions he has to do with a lot of different hands. So it typically uses a nurse or someone to assist him, and we're trying to help eliminate that need and make it easier for him and increase his mobility. This problem is common across the US. It's commonly used in every ER. He said every ER has this, and it's very easy to use, and yeah, it has a lot of instruments. So our mission is to have a hands-free retracting and light illumination device. So basically get rid of the need to self-retract, to hold the retractor, and to point the light into the patient's nose. The restraint we have needs to be lightweight so that it can stay up on the face. It needs to be used, obviously, for the left and the right nostril. Easy to use for the physician, disposable and cheap, because the issue is since blood gets on it, they don't want to have to re-sterilize that part every time. So it'd be easier if they could throw part of it away so that they didn't have to do that procedure. So this is the full product design that we came up with. We have the retractor here, so that's going to go into the nose. Then we have a fiber optic wire which carries the light that's sourced from this LED. You plug this into an earpiece, and it is powered by a little battery in here. So that's the full design that we had. We have some videos to show you as well, make it clearer. Sorry. So there's the battery, the LED. You close it all up. Then it hooks on the patient's ear, and then you put the retractor in the nose. And then also, this is just how it plugs in. It's just a little input there, and the light turns on when you plug in the device. Okay.
Okay, I'm talking about the material here. So like Maggie says, our project has two parts. First one is this kind of the tip parts, which go into your nose. This kind of material is made something called a nylon 680. It's a newly developed nylon material that is FDA approved. So it's safe to put in patient's nose without damaging or harming from the plastic materials. And also because the nylon is very slippery, it can function as a natural lubricant. So when it goes in the nose, it doesn't hurt that much compared with other plastic materials, like the one that I'm holding here. And then this is also something called engineered materials, has very good ratio between the tensile strength and also elongations. So the way we put this is we're using the natural elasticity from the materials stuck in the patient's nose, and then function like a spring. That's how we hook up into the nose at first place. And then, next slide. So this base material can be any simple plastic as long as the dimension is accurate enough. And then, as you can see, we're using 3 coin batteries who generate 4.5 volts. That will be enough voltage for illuminating the one LED lights. And then we made 2 metal parts here, function like a battery package in the one in your home, like for laser pointings. And then 2 copper wires, conduct electricity into these LED lights. And then this part we hook up with the fiberglass. And then this actually is our switch. As you can see, we have a function model here. Actually, so okay. So basically, once we hook in this here, the lights will turn on.
Light turns on.
And then there will be lights from the other end. And then when this hook off, that's how we turn on to off. And this is achieved by attaching 2 metal plates up and there. And then when we switch, the circles become closed circuits, so the lights will be turned on.
Oh,
Meanwhile, in the design process, we conduct the finite element analysis just to make sure that our design doesn't have any flaws or like weak points in the geometries. In this simulation, we assume that the compression force exerted by the patient's nose is around 5 newtons. And then we have the stress contour over there. As shown, there's merely any weak points where high stress concentrates. And as the second plot shows, the maximum displacement is found at the retractor tip, where it goes into the patient's nose. And we also have a safety factor contour right here. As you can see, the whole geometry is basically showing in blue, meaning that the maximum, the safety factor is all above 15, which is really good in terms of the robustness of our design. Yes.
Our earpiece is designed like ear-mounted earphones. At first, Professor Wayman recommended us to design as ear glasses, but under consideration, we decided to design it as this because if we design it as a glass frame, it will have three touching areas, which can be hard to clean up. But if we design as a one piece, it can be much easier to clean. And also, not everybody can use to wear glass. Sometimes it will slide down to your nose, and it is inconvenient for somebody to use. This is for design demonstrations. And you see, he wear different ways like this. It is like this, and you can also wear it in the other side, which is suitable for people to have different ears, different shape and different size. So conclusion.
So conclusion. So our design is very minimal in terms of the geometries and parts we have. The retractor is made of nylon, which is safe to use and pretty robustness, because it's a one-time use piece. So we shouldn't worry too much about the material itself. And for the retractor, for the earpiece part, we made it an automatic switch, which it turns on when we plug in the audio jack. And then, so overall, the device should be pretty easy to use. And we also realized that the earpiece doesn't necessarily have to be worn by the doctor, the patient, because the doctor can even wear the earpiece so that the design doesn't require people to put it on and put it off every time. So also in this time, we don't have to worry too much about the compatibility of this piece to different patients with different ear size. And also the retractor is also disposable, so the cost could be cut down significantly on this, because in medical devices they have to clean it, and so which costs too much for the medical device. Also, for the long-term manufacturing, the retractor and the earpiece can be manufactured by injection molding. We are specifically careful with the earpiece design to have a draft angle so that can be take out from the mold. So yeah, that's pretty much all we have.
Excellent.
Any questions?
Excellent.
Oh, yeah. Questions? Yes.
So the cord is part of the disposable piece, so the cord gets thrown out every time.
Yep.
You mean the fiber optic? Yes.
Yeah,
Because it's made of PMMA, which is just a few cents for each piece.
Yeah.
So why do you need 3 coin cell batteries?
So each one is 1.5 and
Yeah.
it's not quite strong enough, and so we want to have the LED light be strong enough so that he can see the illumination. even ideally, we would like to have 2 fiber optic wires to go in to illuminate the area a little more, but we only have 1, so.
And that lasts how long? How long?
The LED,
The batteries?
pretty long time.
Yeah, we haven't really tested on that. So, but I mean, normally LED lights is not consuming that much electricity anyway, so it should be last fairly long times, I think.
Yeah, and we hope to save because you only plug it in when you absolutely need it. And you unplug it when
Yeah,
you
I mean,
don't,
if
so.
this go to like another mature level, we can have like rechargeable batteries in a way, for the ease of convenience.
Okay, so, why again didn't you use the actual cable that you, the fiber optic cable, you use this instead, or?
Oh,
This
no,
is, we
this
just shelled
yeah.
it
This is the fiberglass.
from last time.
Okay.
Basically, there's a one glass fiber inside of this whatever this isolation like protect plastic rubber is, and then that will be the fabric actually is very thin, as you can see it here. So yeah, but there's much like protection for some reasons.
Yeah, because the fiber optic is pretty brittle.
Yeah, it's pretty brittle, I think.
Okay,
So
I
so the-
just didn't imagine that it was going to be that big.
Oh
yeah,
yeah.
it comes. The light comes
Yeah,
out
this is more
right
like
at the end here.
we get
so
from
that's
a
how
friend
big
of
it is.
ours, because if we buy this from eBay, there will be the shipping time will be too long, and then
Yeah.
they will be coming in bulk, so we can't really buy thousands of them. But the actual dimension will be really thin, like maybe 3 or 4 times of the higher diameters, so it should be very thin.
Okay.
Did you think about making it rechargeable rather than using?
Yeah, I was talking to them. Basically, if this go to another level, we can max production this part. There's a chance we can make the battery become rechargeable, so we can charge the battery pack.
We don't
Maybe
even
at
need
the bottom.
a new port for charging. We can just use the
Yeah,
audio jack
same
for
thing.
this part.
But that will be in the manufacturer's side later on, not for the prototype phase.
And this piece doesn't cost too much. Like,
Yeah, this entire thing costs less than $1, even not even $1.
I mean, it's okay, that's what the components cost, but you assemble them into something and you ship it halfway around the world,
Yeah.
and in profit. So what started off as a few cents gets to be
Yeah.
a
Right.
significant number of dollars.
But this you only buy once. That's the good thing. And so the
Yeah.
other part that's
We
even
could
cheaper.
increase this cost by a little bit because this is just a permanent part, so we can bump the cost a little bit more. Has more fancy piece into this, yeah.
What about the evolution of the retractor design? Has that changed much?
The only thing is we have
You
this
had
kind
that
of
very early on.
yeah, we have this a hole here that we can put the fiber into this hole, and then go in through from here. So we kind of guide this fiberglass into certain geometries and to this tip point here. So the lights will be shooting from these directions.
Also, before we wanted to have more of more adjustable things like that, but then we just realized that really they just want to open it to the max that your nose can open it. So why not just put something in there that's going to put that amount of force and open it as much as it can anyway, and have less components.
Yeah. Hasn't it gotten a lot thicker though? I noticed when you put it in that gentleman's nostril, it pretty much plugged out the whole nostril.
It's gotten a little thicker to have the grooves, but then again, when the fiber optic wire is its actual size, the grooves won't need to be so
yeah,
large.
because right now this
and you'll
is
be able to make it
pretty
thin.
large fiberglass. The diameter is pretty large, so we have to enlarge the hole to make fit this in. But for the future, we can severely reduce the diameter, so it'll be thinner.
We didn't want to shell it to its
Yeah.
actual size because we were afraid we would break it.
Yeah.
And you had to modify that head to give it a nostril anyway.
Well, yeah, because it's made out of foam, so it was closed.
Yeah, but
Not be a scale.
Right.
Actual nostril.
Just
well, nostril can be diameter can be very vary. People have different nostrils, so.
But little kids, I mean, obviously got much smaller noses. They're just going to be forced apart, or you're going to have different sizes.
I mean, we could have different sizes, or it could be forced apart. We could maybe ask the doctor more about that because I'm not too sure. But
Okay. So did you try it?
sorry. Yeah.
So if you look at your functionality, so what you're doing is basically you're delivering the bright light to a particular location that you're looking for, right?
Yes.
And it happens to be the application of this nose area. Where else can you use this?
I guess the similar idea is to, when they look at your ear, they have that same idea with the light application. So we kind of stole that idea and put it in the nose. But they do use this very commonly in a lot of other applications. When we spoke to the physician, he said when they do cervical exams they have new, Yeah, they have new devices that allow for more illumination of that because that's kind of a similar situation. So I guess like any other procedures along those lines, this could be applied to in a different format because the retractor obviously wouldn't be the same.
One option I thought about was if your goal is to deliver light to a particular location, instead of having a device that actually attaches somebody's nose, let's say why don't you have someone wear this earpiece, and then instead of this a flexible wire, you have this as a sort of like a bendable little sticker wire, and then as a result, you can actually move the tip of the wire where the LED light is attached, and just shoot wherever direction the patient you want to see it. So you're just basically using patient's ear as a sort of attachment point, but you're basically attaching a light stand on somebody's head and just point wherever they're looking for. So if that's the concept, we can expand this.
Right.
And see that this can be used for ENT wherever.
Yeah, yeah. We just made it specific to this application,
Yeah.
but yeah, it could be used a lot of different
We didn't
ways.
think about the expansion of this because well, kind of only focus on the project, so kind of limited.
Outside the box.
Maybe, but not now, I guess.
Okay, very good. Thank you.